So, Lana, welcome this morning to our science lesson today. Our lesson today will be methods of separating mixtures. I promised you that today's lesson will be a very interesting lesson in knowing how we can be able to separate mixtures. If accidentally we mix something at home, like you can mix some salt and sand, how can we be able to do that and separate the sand from the salt and get it again to maybe use it in your meal? Now, before we do that, yesterday we were mixing with some liquids, and I still have what we mixed, so we can be able to view and see what we mixed. Like this was, if you can remember, this was milk, fresh milk, and cooking oil. You can see still it has the two layers, meaning that it is an heterogeneous type of a solution, meaning that the two liquids cannot mix, and so we call them immiscible liquids. That is cooking oil and fresh milk. I have again another one here of, you can guess what this was. This is kerosene and fresh milk. You can be able to see that they are also forming two layers, hence cannot form a solution. So they are also heterogeneous type of a solution. So we say they are immiscible. We have another one here. This cooking oil and water. You can see that still there are two layers, meaning that it is an heterogeneous type of a solution, and so these two are immiscible. And lastly, we have this one here. If you can remember well, this is water and fresh milk. They mixed well, and you can see even today you can't differentiate the water from the cooking. I mean the fresh milk, meaning that it's only one solution, and so these are homogeneous type of a solution, and so we say water and the fresh milk are miscible. So now that's where we left yesterday, and today I want us to carry out a few experiments also as we continue to look at the methods of separating mixtures. Now we know that we can be able to separate mixtures depending on the substances that are mixed. There are those substances that are soluble and others are insoluble. This to do with a liquid and a solid. But when it comes to liquids, we say they are miscible or immiscible. So in this case, we are not going to look at the miscible ones, because, like for example, milk and water, we cannot get back the substances. So we are only going to deal with soluble, insoluble, and immiscible substances. So this one will not be able to deal with it because, of course, we cannot be able to separate that. I understand that in class 6, you also checked solubility of some substances, and you also discussed about magnetism, which I'll cover later after this subtopic. I'll cover magnetism, and we shall know that there are materials which are magnetic, others are not magnetic, and so we come to that. I think in class 6 we discussed about the magnetic force, and which we say is a force is a pull or a push, So I want us to begin, and to make this lesson a very interesting one and a very brief one, I want us to deal with the methods in a table, the methods of separating mixtures in a table. Now here we are going to do a few things. Number one, when we are choosing a method of separating mixtures, we are going to consider, number one, the type of mixture. When I talk about the type of mixture, we are going to say whether they are solid, that is a mixture of solid and solid, or a mixture of solid and liquid. We will also talk about a mixture of liquid and a liquid. So when we talk about type of mixture, we are going to write this. Then from there, after knowing the type of mixture, of course we'll have started with the method of separation that we are going to pick. If you pick a certain method of separation, what factors are you going to look into for you to be able to choose that method of separation? So the next thing will be the factor to consider. Factors to consider. For me to pick a certain method like magnetism as a method, what have I considered? Are the mixtures, is the mixture, do we have some magnetic materials in that mixture for me to pick that particular method magnetism? So that is what we call the factor to consider. What are the factors that we're considering? What are we saying that we can use sieving? Because of these reasons, these are the reasons. The reasons why you pick a certain type of method of separation of mixtures. So I'm going to draw a table here for us to be able to do that very well. Learn, I want you to follow keenly, because I'm going to have a table like this. Going to have a table like this. In our table here, we are going to have 3 divisions. The first division will be the type of method of separating the mixture. So the method. Number 2, we are going to have the type of mixture. In the type, I've said it can be solid, liquid, and then we give an example. Then here we come factors to consider. What are the things that we're looking at for us to pick that certain type of a method? So we have several methods, learner, of separating mixtures. Number 1, we have a method called winnowing, which most of us we have done at home. Winnowing. Then we have another method called sieving, the method. We have a third method called decanting. We have filtering. We have evaporation. We have I talked about picking. We have a picking as a method, and then we have magnetism. All those are methods of separating mixtures, depending on the type of mixture. So we are going to begin with one, that is picking. Picking as a method. This is one method of separating mixtures. You can decide to pick from somewhere, so that you can be able to separate those mixtures. So which are these types of mixtures that we separate using mixture? The type of mixture will be a solid and solid mixture, solid and a solid mixture. So the two materials, all the 3 materials, whatever materials they are, even if there are 3, all of them must be solids. So it's a solid mixture. Let me give an example. A good example is maize and beans. If you look at maize and beans, all of these are solids. Now you can be able to see that well. So the type of mixture is a solid and solid mixture, and then we have an example. Maize and beans is one example. We can also have another example, maize and wheat. Maize and wheat. Those are enough. Both of them, of the substances, are supposed to be solids. Then when it comes to the factors to consider, what are we considering? For me to be able to picking as a method to separating a certain mixture, what have I considered? These are the things that we consider. For you to be able to separate this type of mixture, you need to consider the following. Number 1, the size of the materials. Size of the materials, that is large, big, and small. big and small. The size of the materials, that is big and small. Number 2 thing that you consider is the color of the materials. Color of the materials. Now, I want us to look at this first example that I gave here, maize and beans. If you look at maize and beans, maize is white, beans can be reddish or mixed color. So you can clearly see that there are two different colors. So you can decide to pick the one that is white and leave the other one which is red. So you can pick the white, which is maize. So you'll be left with maize on one side, and then you'll have beans on the other side, using color. Then we talk about size. Let's look at maize and wheat. Wheat is small compared to maize. So you only pick the bigger one and leave the small. So if you pick maize, you'll be left on the other side with wheat. So you'll have separated maize and wheat using picking as a method. But consider this. Look at the factors to consider. These are very, very important. So here we consider size and then color. Size and then color. I hope, learner, you have understood. You can add more examples of mixtures that are solid and which have these characteristics, size and color. Number 2 method, so we put a line there. Number 2 method, we have winnowing. Winnowing. All of us know winnowing. You are going to have something, be a big plate that you have mixed some solids there, and then you start throwing them up and down to ensure that the lighter ones move away. Now, we begin by talking about the type of mixture. What type of mixture can be separated using winnowing? That can also, supposed also to be a solid and solid mixture. Both materials are supposed to be solids. Solid materials. And so, we can be able to give an example of that. We can have maize and husks. We can also have rice and husks. This is maize and chaff. Let's talk about maize and chaff. Maize chaff, and then rice and husks. When you talk about maize and husks, if you look at this, husks are going to be very light compared to maize. And then if you look at this, rice is going to be heavy compared to the husks. So what are we saying here? What do you consider for us to pick winnowing as a method of separating mixtures? For me to pick winnowing, what have I considered? Number 1, I've considered the materials. We talk about heavy and light materials. Simply, we can talk about, we consider the weight. That is heavy and light. Heavy and light. So the one that is heavy, that is maize, will be left on the bigger plate you are using to throw up and down, and then the lighter ones, which are the chaff, will be blown away by the wind. So here we say the lighter materials will be blown away by the wind, and you'll be left with your maize or rice, and you start cooking it now because you have separated the two. I hope you understood, learner, what we said, that in winnowing we are considering the weight of the materials. This is very, very important, the weight of the materials, heavy and light materials, so that the light materials will fly away, will be blown away, and you will remain with weight the heavy materials, meaning that you have maize on one side and chaff has gone. Let's move on to the next one. Let's move to the next one. The next and third method of separating mixtures. The third method of separating mixtures Our third method is going to be sieving. Third method is going to be sieving. Sieving. Going to be sieving. I understand most of you have gone to the posho mills, whether up country or here in town. You find that there's something put just outside the posho mill looking like this. Then some wire mesh here, like that, where you come and place your maize there. If the maize was not clean, place it there and then you start sieving, so that the chaff will fall down here, the small particles will fall down here, you remain with your maize on top of this sieve. So what type of mixture are we considering here? Should be a solid and solid. A solid type of a mixture. And here we're going to give an example. We talk about maize and chaff. Maize and chaff. E.g. maize and chaff. You can be able to separate maize and chaff either using winnowing or sieving. And here, what are the factors that we are considering? The factors that we are considering is the size of the materials. Size of the materials, that is large and small. Sorry, big and small. The big material here is maize. The small one is chaff. So the chaff will go down and then remain with maize on the sieve. So maize remains on the sieve as the chaff goes through to be collected at the lower side of the chaff. Side of the sieve. So that is it, learner. And when you place maize there, the maize will remain here, then chaff will be collected at this point. You have separated the chaff and the maize. We move on, learner, to the next one. So we can have more examples here, like we can have wheat flour and ash. Wheat flour and ash. I know you're wondering how wheat flour. But to talk about wheat flour, we talk now at the size of the sieve. You can have sieves which are small sized. Not necessarily to have a big holes, big spaces. We have those sieves that have small spaces. So the wheat flour will go down as we remain with the husk on the other side. So those are enough examples of such mixtures. The next one is decanting. Decanting. And so decanting will take a bigger space. So let's wrap here. Decanting as a method. Decanting. Before decant. Now, what type of mixture can be decanted? We have two types of mixtures. Number one, a solid and liquid. A solid and liquid mixture. A good example is maize and water. We can talk about sand and water. This is an insoluble solid in a liquid. Insoluble solid in a liquid. The maize is insoluble, the sand is insoluble. Number two type of mixture. We have said solid and solid. We have number two, immiscible. Immiscible liquids. That is liquid and liquid mixture. And this liquid and liquid mixture can be either kerosene and water, Then we have cooking oil and water. Cooking oil and water. These mixtures, kerosene and water and cooking oil and water, are forming layers. They are not forming a solution. And therefore, we can decant to get one liquid on the other side and leave the other one. The less dense goes on one side, and then the denser liquid, which is the one which is heavier, is left. So let's see the factors to consider. Now, because we have solid and liquid, here we consider the solubility of the materials. That is an insoluble solid in a liquid. So what type of mixture can be separated with that is an insoluble solid in a liquid, and I've given an example of maize and water and sand and water. Maize is insoluble, sand is insoluble in water. Then number two, because we talked about something else here, liquid and liquid. So remember what I said yesterday? In liquids we don't talk about solubility, we talk about miscibility. So we don't say that liquids are soluble or insoluble. No, they are either miscible or immiscible. So in this case, we are going to say immiscible liquids. We are going to separate immiscible liquids using this particular method of decanting. And so we can give an example. We can have examples I've given: kerosene and water. And what will happen? This is explanation. The less dense is collected in a separate container. The less dense, we are going to talk about the density. I don't want to say the heavier or the lighter. That is because that is not right. The right thing is less dense and dense. So the less dense is the kerosene. The less dense in this case is cooking oil. We are comparing the densities with the one of the water. Water is denser compared to kerosene. So this is less dense, this is dense. Cooking oil is less dense, this is more dense. So can you be able to do that? So if you try to separate maize and water, you are going to filter the water on one side, and at the bottom you remain with your maize. So water will go on one side, then maize will be left on the other side. I'm interested in this part, immiscible liquids. You remember Lana yesterday we did a mixing of liquids, and so we can have those liquids that we used yesterday. The ones that formed layers, we can be able to separate them using this method. So we begin by separating kerosene and water. We have kerosene and water. My kerosene and water is here. So we are going to separate kerosene and water. So we are going to filter carefully. You can be able to see that kerosene is on the upper part. You have seen the layer. So you are going to gently filter this kerosene to this other container. Just like that. Carefully. Until all of it comes to the other side. I want you to see, Lana, that we don't have another layer here. You can be able to see clearly that this is water, this is kerosene. Though the kerosene might have some traces of water, because this is not a surest way of separating immiscible liquids. But at least you can get the kerosene on one side, you have water on the other side. So Lana, you can be able to see that. Try to do it at home in the mixtures that you mixed yesterday. Now we are going to separate the other one, which is we have cooking oil and water. So my cooking oil is here, and then I have this empty container here. So I'm going to carefully remove this cooking oil into the other container. So you do it gently so that you don't empty the water to this container. So you can see we have like I said, we are not going to remove everything, but at least you can see the water, the amount of oil in the water has decreased, meaning it has entered here. So this is oil, you can see, but it has some traces of water. You can be able to see the amount of cooking oil in this side has reduced, and so it has come to this end. So that's how we can be able to separate immiscible liquids, Lana. So having done that, we move to the next method, and which is filtering. Filtering is method number 5. Method number 5 is filtering. I understand in lower classes in class 3, you try to separate some insoluble solids using a piece of cloth, where you tied a piece of cloth on a container, and then you pour some a mixture of insoluble solid in water over it, and you collected some water inside that container, and some pieces of maybe sand were left on the other side. If you didn't know what you did, then you separated those mixtures using a filtering method. So what are we separating here? The type of mixture we are separating in this is a solid and liquid mixture. A good example is sand and water. If you want to separate sand and water, you can use filtering method. So what are we doing? The factors we are considering is insoluble solid in a liquid. Insoluble solid in a liquid. Insoluble means that it does not disappear in the water, so it remains there. So what is going to happen, that the water will be filtered. Water will be filtered into the container, while the sand remains on the piece of cloth. I'm going to draw to illustrate the type of experiment I'm talking about here. So this is a container, then you tie onto it a piece of cloth like that. So you're going to pour your materials here. So you're going to have some water here. Some water is going to come there. So once you pour the materials here, because there's a piece of cloth with some fine oils, the water is going to drip downwards like that. So these materials are solid materials. The solid materials will be there, then water is left on this side. Now Lana, this one comes in an exam, and you are told to label which one is a filtrate and which one is a residue. Listen carefully, Lana. The solid materials are known as residue. So this is what we call residue. Residue. Then what is collected in the container, that is the water. The water is called filtrate. 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 From the word filter. So filtrate. Filtrate is the water, then residue are the solid materials. So get that one clear, well, Lana. Then we can also have, sometimes you want to use a filter paper. You can have a filter paper, which can form it's just something like a funnel. Then you place it inside here. You ensure that you stick it using some water. You just put some water on the sides of the filter paper. Then you pour your materials inside. So the solid materials are going to remain here. So the residue is found there. Then water is collected on this point. We call it the filtrate. the filtrate is going to remain there. So how can you be able to form that filter paper? It's very simple. To make this filter paper is very simple. Have a circular paper like this. You see, a circular paper like this. Then fold it at the middle like this. Come up with half a disc like this. Then fold it to become a quarter. Then open it. Open it like this. You open it by inserting your finger, just like that. Learner, you have formed a filter paper. You open it like this. You can be able to see my filter paper, a funnel. So you place it now here, like this. Ensure you pour some water. You just have some water here, then place it in the bottle like this. Then pour your materials. But you must be very cautious that you don't make a hole here. The water will make the hole for itself. So water, when you pour the materials here, maybe the insoluble solid in the water. So you place the materials here, water will make its all here, and then start pouring down inside the hole. So that's how you do it, learner. You can improvise one at home and be able to form a filter paper which can be able to filter that. So look at this, the filtrate, where the filtrate is, and the residue. That, remember that our material is solid and liquid, and insoluble, solid in a liquid. That is a factor we consider. Is this material insoluble in water? Yes. So we can be able to pick filtering as a method. Our next method, of course, is going to be evaporation as a method. I'm going to talk about the remaining two. We are remaining with two, evaporation and magnetism. Now, we have evaporation here as number 6. Evaporation. I know you are wondering how we can be able to use evaporation to separate mixtures. Take for example, if you accidentally mix salt and as we did here, when we are doing looking at the solids that dissolve in water, we mixed some salt and water, and after stirring, the salt disappeared into the water, meaning that it dissolved in the water to form a solution. So what you are going to do here, it is that water that is salty that you are going to evaporate. So the water that is salty, you place it in what you call evaporating dish. If you don't have an evaporating dish, you can have a small sphere that is very clean. Then you put the water inside and apply some heat. Water will be evaporating because you know after you evaporate, you put water under very high temperatures, it becomes gaseous form. So the gaseous water will evaporate, and you remain with some, solid granules. The solid granules, the solid particles are are salt. So what type of mixture here is a solid and liquid mixture. An example is salt and water. And what factors are we considering? This is soluble solids in a liquid. Soluble solids in a liquid. The solid is salt, it is soluble in water. So what will happen? Evaporate the salt water, the salty solution. Remember, it is a solution, the salt solution. Water will become vapor, and disappear in the atmosphere, leaving what? Leaving salt particles in the sufuria. In case you're using a sufuria, or evaporating dish. So you are going to realize that after you evaporate the water, that's salt solution. The water is going to disappear into the atmosphere as water vapor, and then you remain with salt particles at the sufuria. You have separated the two, and you have gotten back your salt. You can use it now in your food. So there's one question that comes in the exam. Why is it that many people do not want to use evaporation as a method? Why is evaporation as a method discouraged? Why is it discouraged as a way of separating mixtures? The reason is simple. The reason why evaporation is discouraged in separating mixtures is that you only recover one item, one substance. The other one is lost. You can remember that our water was lost in the atmosphere. So we don't have water. But if we can have a method that will get the two substances, then we'll use that method instead of using evaporation. So the reason why evaporation is discouraged as a method of separating mixtures is that we only get one substance. We recover one substance. So one substance into brackets, salt is recovered. So the water will be lost in the atmosphere. So it's not a good method of separating mixtures. And so we are remaining with one method. And the one method we are remaining with is the method magnetism. That method will be taught in the next lesson. For the reasons that we have not covered magnetism in class 7. So after covering that magnetism, I'll come and teach that method. It is very easy for you to understand what we mean by magnetism as a method of separating mixtures. So now we have gone through various types of methods that we use to separate mixtures. We have seen picking as a method of separating mixtures, where we say in picking we look at the type of mixture is supposed to be a solid mixture. Like for example, we have maize and beans, and so here we consider the size of the materials and the color of the materials. So we pick the bigger materials and we remain with the small materials on the other side. Then we looked at sieving as a method, and sieving we also say that we consider the size of the materials. These materials are supposed to be solid materials. So the smaller ones go down the sieve and we remain with the bigger materials on the other side of the sieve. So that is sieving. Then we went to decanting as a method. Decanting as a method, we say there are two types of mixtures that can be separated using this method. That is solid liquid mixture, and then liquid mixture. On the solid liquid mixture, we said this is an insoluble solid in a liquid. After decanting carefully, you will remain with the solid materials on one side and the liquid will go on the other side. Then we came to liquid materials, where we find these are immiscible liquids, like for example water and cooking oil. You generally remove the water through to another container. You remain with water on this side, and the other side you remain with cooking oil. Of course, after that we went to evaporation method, where we say that the method is used to separate a solid liquid mixture, but this solid is supposed to be soluble in the liquid. And so we got an example of a solid in a liquid, that is salt, where you evaporate, you put the mixture under very high temperatures, you evaporate the water into the atmosphere, you remain with the salt particles at the base of the sufuria. And so we said it is not encouraged, because you only remain with one item. Out of the two substances, you remain with one. So that's where we ended up. Of course, as I said, tomorrow or in the next lesson, we shall be able to handle magnetism as a way of separating mixtures. Go through this, what we have done today, and ensure that you know the type of mixture to be separated and the factor to consider. That will be very, very important for you. So thank you, Lana, for listening. Go through this work. see whether you can be able to read and understand them well. Where you get a problem, you raise, you pose a question, and I will be able to answer you. So until next time, have a blessed afternoon, and may God bless you.